Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 7 of the November daily Leetcode challenge, and we again have a medium level question for us. So without wasting your time, I will be just quickly going over the Java solution. I'm expecting that by the time you're seeing my video, you would have already gone to the question and will already tried to solve it. So I'm not going to waste much of your time, and I've already given a detailed explanation of this question with multiple examples in the Python video. You can check that already. I can give the description in the description. I can give the link of that video. So let us quickly jump to this particular question. Okay. So we have given a candidate array. What we have to return? We have to return the length of the largest combination. Okay, we have to return the length of the largest combination possible out of the elements in the candidate array, such that the bitwise end of all the elements in that combination is greater than zero. Okay, I repeat, we have given a candidate array. We have to return an answer which is integer. So what is this answer? Basically, this answer is going to be the length of the largest combination of candidates. Okay, that is out of this array. You have to take a collection. Okay, you have to take a combination out of this candidate array, such that the largest combination among those candidates, okay, has you have to take the combination in such a way that, see, first of all, what you have to do, select combinations out of them, okay, and take the bitwise AND. Okay, sometimes you will get a zero answer, sometimes you will get a non-zero answer. Okay, so among the non-zero answers, what you have to do is you have to find out the largest combination and you have to return its length. That is going to be the answer here. Okay, so what you have to return, the largest combination, that is the length of the largest combination among candidate elements, okay, with the bitwise AND greater than zero. Okay, with the result of the bitwise AND greater than zero. I am assuming that you already know what is the bitwise operator. You can check out my other video if you really need. I've given some examples in that, and the best thing will be to google out what is a bitwise AND operator to get the idea on this question. Okay, so because this whole question revolves around and. Okay, if you are not aware of what and is, I am damn sure you won't be able to understand the solution as well. Okay, and just try to solve, quickly do a google search on what is the and operator and what are left shift, because I am also going to use the left shift basically to identify in which particular bit of the number the bits are set. Okay, so I'll be using that. So you can just quickly google these two things and come back to this video if you're not sure on that. Okay, so now coming to this particular video, first thing that I will try to do is see what I'm going to do. One thing is clear, right? We have to return the length of the largest combination. So when we talk of a bitwise and, what happens? See, if a particular bit is set to one in among all the candidates in a particular combination, only then the answer will be non-zero. Do you agree with me in that? Okay, I've given the examples in the other Python solution. You can check that out maybe. But since you're coming for the Java solution, I'm expecting that, yeah, you are a more than average coder, and you are knowing what is and what are the consequences of and, right? So only if a particular bit is set to one, okay, among all the elements in a particular combination, only then the bitwise and among those elements will return a non-zero answer. Okay, that's as simple as that, right? So I'm assuming you know this. If you don't know this, please go and do some research, go do some homework, or you can watch my other video. We'll get some answer in that. Okay, I'm assuming that you know this. I am proceeding further. So what we have to do, I will go through. What I will do is I will set a array. Okay. Okay. Now, first of all, before that, see, the value in this is going to be up to a 10 power 7, right? Sorry, 10 power 5. Okay, the value is, okay, 10 power 7. The length is going to be 10 power 5, but among each value is going to be 10 power 7. So can you quickly tell me how many bits we need to store a value which is of 10 power 7 range? Okay, can you quickly tell me? So here is a calculation for that. Okay, so what I am doing, see, when I say bit, what are the values it can store? 0 and 1s. Okay, so among those 0 and 1s, I have to store a value which is of 10 power 7. Okay, how to do that? So what we have to do, let us say n is the number of bits that we require, so 2 power n should be almost equal to 10 power 7. Okay, so almost equal, I'm not saying exactly, it should be almost equal to a value which is of this range. Okay, in the range of 10 power 7. Okay, let us say this. So what I have to do, I am applying log 10 on both sides. Okay, so what will happen to this will become 7, as you can see, and RHS will become 7. If I apply log 10 here, what will happen? And will come here, and we will remain with log 2 base 10. Okay, if you solve this, we'll get n is equal to 23 point something, and since we have to go for the upper side here, so it will be around 24. Okay, so n will be almost 24. So basically we need 24 bits here to store a value which is in the range 10 power 7. Okay, that is as simple as that. So again, I'm doing the same thing. I am going to take a integer array of, you can see, uh, yeah, you can take an integer array of length 24 here, because it's starting from 0 to 23. Okay, these are going to, what it will store, see, set bit count. Okay, this is the array name. Okay, set bit count of I will be the count of elements in the candidates, among the candidates. Okay, count of element among the input array for which the ith bit is set to 1. Okay, okay, let us go back to that again. Please listen what I'm saying. Set bit count of I, that is the ith element in this particular array. Okay, set bit count of I will be telling me the count of the elements in the input for which the ith bit is set to 1. Okay, I am assuming what I'm saying you are understanding. Okay, set bit count of I is the count of all the elements in the input for which the ith bit set is 1. Okay, so what I'm going to do, I'm going through two for loops. Okay, first for loop will be, yeah, I'm thinking, first of all, I'm going from 0 to 23. Okay, this bit position I'm going from 0 to 23. Okay, so for each bit position, what I'm going to do, I am going to go through all the limits and I'm going to check whether that particular bit position is set to 1 or not. Okay, my approach is very clear here. I will be going from 0 to 23 bit positions. Okay, for each bit position, let us say for bit position 0, I am going through all the elements and I'm going to check whether that particular bit is set to 1 or not. If that bit is set to 1, I will be updating that particular bits, that is, let's say 0th bit. So I'll be updating the 0th index here, the value in the 0th index I will be changing, that is, I'm adding 1 to it, as simple as that. So for that reason, set bit count of I, that is, set bit count of I will be number of elements for which the ith bit is set to 1. Okay, as simple as that. So what I'm doing, I'm going from 0 to 23. Okay, for each bit position I'm going through all the elements. Okay, this is a for each loop. If you're not aware, you can use this. Okay, this is slightly easier to write and is very easier to read also. What I'm doing here, I'm doing num and then this particular thing which is not equal to 0. What is this, by the way? I've explained this in detail in my other video, in the Python video. See, what we are doing is we're doing a left shift here. Okay, I'm left shifting one by certain position. Okay, so what this will basically do, see, nums will have a, if you see the binary representation of any number, basically it will have zeros and ones, right? For each bit, what, see, in this case I'm only concerned about this particular position. Okay, so what I'm trying to do in the nums. Okay, in that, among its, if you take its binary representation, whether the this particular position, okay, the position represented by bit position is set to 1 or not. I just want to know that. So how I will know that? I will be taking that particular bit here. Okay, I will be multiplying that with 1. Okay, if it is 1, the answer will be 1. If it is 0, the answer will be 0. Okay, so the idea here is, if the answer is 1, that means this particular bit, okay, this particular bit in nums is set to 1. That is the basic idea. So what I'm doing, I'm keeping nums as it is, but I'm left shifting 1 by this many times. Okay, how many times? This many times. Okay, this will, you know the number will become big, such that when the AND happens, the bitwise AND happens, the bit position, that is the ith position of this, okay, will be multiplied with this. Only if it is 1, the answer will be non-zero. Okay, as simple as that. So the idea here is, if this particular thing is non-zero, that is, if this condition is true, that means the ith bit in that is set to 1. Okay, that's why I'm doing set bit count of bit position plus equal to 1. Okay, that is the basic idea. Once I come out of this loop, okay, I have all the counts here. Okay, I have all the counts here. What I will be doing, what is the maximum count in this, I have to return that as the answer. Okay, I'm initially answer with 0. I'm going through each element of this particular array, whichever is the maximum element, I'm taking that, I'm returning that as the answer. Okay, as simple as that. So what is basically happening in there, see, we are doing the AND operation, right? So AND operation will return a non-zero result only when all the elements have a particular bit set to 1 and among all the elements that we are considering. Okay, so how to find that? To do that, I am saying the same thing. Okay, we need 24 bits for the 10% value that we have. Okay, the 10% value. Okay, I'm going through each of the, I would need 24 bits for that. I'm going through each bit, I'm checking in all the numbers whether that particular bit is set to 1 or not. If that particular bit is set to 1, okay, I'm increasing the count here. Okay, and then finally I am checking which particular count is higher, that is, which particular bit is given the higher count. That is going to be my answer. I'm returning that. So if I can quickly run this and show you, this works. Okay, I've already submitted the solution and what it got accepted. Okay, as you can see here, it got accepted. So if you try to talk about the time and space complexity of this, okay, so coming to time complexity, see, though we have the outer for loop here, but remember, it is not dependent on n. Okay, it is not dependent on n. So the time complexity will be O of n only, because see, the idea here is how many times this for loop is running. It will be running for 24 into n times. Okay, see, this inner for loop is running for n times. Do you agree with me? Okay, and this outer for loop is running for 24 times. That is for each loop in the that is each loop in the outer loop. This will be running for n times. So it will be running for 24 into n times. Okay, and for this, finding this also, it will be running for 24 times. Okay, so the idea here is 24 into n plus 24 times it will be running. Okay, but the time complexity we always tell in terms of n. Okay, so 24 is a constant, we have to ignore that constant, we have to go for the upper limit here. So in terms of the big O notation, it will be O of n. Okay, the time complexity will be O of n. Now coming to space complexity, again, this is something that we are creating and it is taking the space, but it is a constant space, so it is not dependent on n as such. Okay, with n, if n increases, this will not increase, it will remain constant only. So again, this will not be counted towards the space complexity, though it will, yeah, it will be consuming memory and it will be slowing up solution, that is true. But in terms of the big O notation, this will not be counted towards the space complexity, and we have the constant space complexity here, because if you see, we have nothing which increases with n. Okay, as simple as that. So I've explained about the time and space complexity, and I've also mentioned about a disadvantage that we have here, that it is occupying space and it is not considered good. So can we avoid this? Okay, that is what we are going to see in the second approach. Okay, so basically what we need is, see which particular bit is having the highest count. Okay, that is what we need, because we're returning that only, right? We're returning that only here, if you see. So instead of storing all the counts, we can just focus on the count which is the highest. Okay, that's what we're going to do in the second approach here. Okay, in the second approach, everything is same. Okay, if you see in the place of the array, I have replaced this the array, right? In place of this, what I'm doing, I'm just keeping an integer. Okay, what is this max count? That is max set bit count equal to 0. Initially it will be 0. This is the same. Okay, this is the same, and here also everything is same, but only difference here is for each bit. Okay, I am starting a count. I'm declaring a count equal to 0, and whichever element has that particular bit set, I will be counting them through this. Okay, that is whenever the bit is set for a particular number, I will be updating my count. Is count is equal to 1 through this. Okay, so this particular count will tell me which all elements have, that is how many elements have this particular bit position set. Okay, this particular count will tell me that. Okay, so what I'm doing, after this I will have the count that which all elements have this particular bit set. The count for them is this. Okay, so after I come out of this for loop, okay, I will have that count. Okay, what I'm doing, I see this is the count for this loop. In the previous loop some counts will be there, right? I am what I'm doing is I am taking max of them. Okay, I'm taking max of the current count and the previous count that we had. Okay, I'm storing that in this. Okay, so whatever previous count that I had and the current count here, whichever among them is max, store it to max count bit count. Okay, which the previous value of this, the new value of this. So this will be updated after this. Okay, and finally I'm going to return the same. Okay, this value which is having the maximum count, I will be writing that in the last. So if I can quickly run this and show you, you will see that we can avoid the errors of this particular approach. Okay, so this can, you can proudly say that yeah, this is absolutely of one space complexity, because here obviously we are not using anything. Okay, in previous solution also it was a constant one, but still we are using something, but here we are not, you are not using anything. Okay, we are not declaring any array as such. Okay, only we are declaring certain variables as such. Okay, so we have to return this. So what we are doing here, basically this count will tell me how many, but in that particular bit, okay, among all the elements, this particular bit is set in how many elements. This I'm going to store here. Okay, which one is the max I'm going to store here. After all the loop completes, I can return this as the answer. So yeah, fine, that was for this question, and this was on. See, if you are aware of this concept, I'm damn sure that it will be tricky for you. I mean, it will be, we'll have to apply this concept, but if you have solved the similar question before, this will be easy for you. See, after that was all for today. This was a good question for you to realize, okay, how important this bit manipulation topic could be, okay. And we'll also get to learn about this left shift right shift operators. It's really good to know this, because sometimes you can solve questions using these things. And see, the idea here is within an integer, you can, we will appreciate basically like within a, when you say 4 bytes, okay, integer 4 byte thing, but how many values can store in that, you can get to know that, okay. Because in the approach one I have shown you like this calculations, okay. See, 10 power 7 value can be stored here, okay. From 0 to 10 power 7, you can basically store just with 24 bits. That's what we are trying to say here, right? So this is something that you can be knowing, because in the face-to-face interview you will have to calculate these things. Okay, otherwise you will never get to know whether you have to take 24 or you have to take 32 or 31. Okay, basically 31. 31 is the higher limit. Okay, integer. But yeah, here we can only limit to 24, because the a value that is going to come is not going to cross more than that. Okay, we don't need bits more than that for the value that is going to come in the input. So yeah, that was all for today. I can give the solution in the comment section, and also I will give the link for the Python video. You can check that out if you are, very first time you are solving this kind of questions. You can check the Python video. Python will be slightly easier for you to understand that. Okay. So yeah, that was all for today. See you tomorrow. If you like my efforts, please do consider subscribing to the channel. This really gives a lot of motivation to continue further. Spread these videos among your friends and among your family members who are interested in this particular field. The IT field. These things can help you a lot in your interview. You will not realize its impact, but eventually you will get to know that. See, the only difference between you and a big role is this coding part. Okay, everyone has the technical knowledge. Okay, but this coding part is something that comes only with a lot of practice. Okay, there's only something that will be missing in you, and that will be the only gap that you have to fill in to get a much higher role, the much higher salary that you are dreaming for. So yeah, that was all for today. See you tomorrow. Please do appreciate the efforts. If you really like, if you get something out of it, definitely you should feel like giving a like here. Okay, see you tomorrow. Thanks a lot.